Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have an interesting problem that we're about to do, right? You know what I'm saying? So the problem's called, guys, course schedule 2, right? So we've already done course schedule 1. So if you guys haven't seen that problem, highly suggest you guys go check it out. I went through a lot more details. I'm saying a lot of details actually. Yeah, so let's get started, right? So he says there are a total num courses, right? You have to take labeled from 0 to num course minus 1, right? It says you're given an array of prerequisites where prerequisites of I, right, at a particular index, right? Pretty much gonna store like a pair, I'm saying, of data, or I'm saying for us to use and do stuff, right? So he says it indicates that you must take course B first if you want to take course A. Pretty much it's saying that before you take course A, right? You know what I'm saying? Because they told us that the prerequisite thing is going to hold a list of prerequisites, right? Pretty much going to tell us to take course A, we have to take course B first, right? That's pretty much the relationship that those elements have with each other, I'm saying. Says, for example, right, pair 0, 1, right? Indicates to take course 0, you have to take course 1 first, you know what I'm saying? So that's what they're showing here, right? So to take course 0, right? If I want to take course 0, I have to take course 1 first. So very, very important. You understand that, right? It says return the ordering of courses you should take to finish all courses, right? If there are many valid answers, return any of them, right? If it is impossible to finish all the courses, return an empty array, right? So this is a very interesting guide that they tell us all that, right? Yeah, so if we can't take all the courses, we return empty array, right? Okay, cool. So we'll give it a couple of examples. Num course prerequisite, right? And this one pretty straightforward. You know, to take course 1, we have to take course 0. So we can indeed take all the courses, what I'm saying. So it's perfectly fine, right? As the order, you can take course 0 first, right? And then after take course 0, you take course 1, right? Pretty simple. It says num courses, right? Prerequisites. So there are a total of 4 courses to take, right? So for this example, right, you see we take 0. We can take course 0 before take course 1, right? You know what I'm saying? They pretty much tell us the example, right? And this is the ordering that we have, right? And they also mention that so another course you could do it, right? I'm saying it could be 0, 1, 2, 3, right? Or it could be 0, 2, 1, 3. I'm saying. So that's what they mention here, right? So don't worry, I'm gonna go in details to the examples real quick. And then we got one course we need to take, right? And there's no prerequisite, right? So we could easily take that one course that we have to take. You know what I'm saying? They said that the courses are labeled from 0 to course minus 1, right? So 0's in there. You know what I'm saying, if we take one course, it's gonna be course 0. You know what I'm saying, and there's no prerequisites because there's only one course. You know what I'm saying, that we have to, you know what I'm saying, take, guys. So you guys already know that based on the other video that I did, guys, that it's gonna depend on pretty much, guys, we're going to be using pretty much, you see that we have a bunch of elements, right? And those elements, right, they have dependencies on each other, right? So, and we're asked to find the ordering, guys, right? So whenever we asked to find ordering of elements, guys, we already know what's up, right? Especially when the elements, they have dependencies on each other. So we know the topological store is used to find a linear ordering of elements, right, that have dependencies on each other. So we know the definition, we know all of that, right? So we automatically click yeah, so a topological store is used to find so we can find the topological ordering, right? And that's pretty much what they're asking for, guys, the ordering, right? You know what I'm saying, the topological ordering of the elements, right? And then if we're able to do the topological ordering, right, we return the actual answer, right? So we're gonna run through a couple of examples real quick, and hopefully, you know, you guys can understand the thought process, right? So pretty much they tell us that we're going to be giving a list of prerequisites, right? I'm saying it's going to be a 2D array, right? And then for each array right in there, right, we're going to have 2 pieces of data, right? I'm saying pretty much 2 courses, pretty much one showing that one is a prerequisite for another course, right? I'm saying B is going to be a prerequisite for what I'm doing. B is going to be a prerequisite for this one, right? For A, right? So the way that it shows, right, I'm saying 0 will be a prerequisite for 1 for this example that I have here, right? And yeah, so pretty much, guys, we know topological sort works, guys. You know we need to have a pretty much what we're going to do first, right? We're going to build the graph, guys. So we're going to build a graph, and we need to, so pretty much, all the nodes, so pretty much the courses, right? They're going to represent nodes and the graph, right? I'm saying, and then we're going to have some kind of the edge, right? It's going to be a directed edge to show the relationship between the different courses, right? Between the different nodes, right? So we're going to be using a directed edge, guys, to show the relationship that we need to go from course A, right, to go to course B. I'm saying we can't go from the other way around from V to U, right? No, we can't do that, right? So this could easily be represented by having a directed edge, right? We have 0 from this example, right? Make it clear for you guys, right? 0 will point to 1, right? To signify, guys, that to go from course can go from course 0 to 1, right? But we can't go from course 1 to course 0, right? Because 1 is not a prerequisite for course 0. It wouldn't work, you know what I'm saying? So this is kind of what we're going to represent it as, right? A directed graph, right? And then we're going to apply the topological stuff, right? Hierarchical story, stuff like that, right? So, yeah, so you guys are following. So let me know if you guys are following in the comment section, guys. So we have num courses, right? What I'm saying, and we have a prerequisite thing. And this is the first example that I'm showing you guys right now, right? So the first example, right? We have a simple one, right? Pretty much we build a graph, right? I'm saying the graph is 0, 1. 0 is a prerequisite for 1, right? So 0 points to 1, guys, right? So we have that example right there, right? So we return, so we apply topological sort, and we return 0, 1, right? See, this one's a pretty simple case, right? So nothing really going on, like really, I'm saying. So because of that, guys, so we're gonna do the second example, right? It's a lot interesting, a lot more going on, and that's why I know that that's the perfect example for us to go over, guys. So the way we're gonna solve it, guys, is gonna be intuitive, guys. So pretty much, guys, I told you guys we're gonna build the graph, right? I'm saying it's gonna be a directed graph, right? So yeah, we're gonna have the graph and we're gonna apply the topological ordering, guys. So I have videos on topological sort. Something's gonna pop up already, where I went in detail, right? How it all works out. I'm saying, okay. So we're gonna quickly run through it, guys. So what we're gonna do, guys, we know that so right now we have the graph, right? You know what I'm saying? So we got 4 courses we have to take. So the courses are 0, 1, 2, and 3, right? You know what I'm saying? So that's how they're labeled, right? Because that's what they said in the question, right? And you're probably saying, what are those parentheses things, right, that I have besides them, right? So those represent the n degree, guys. So we need to keep track of the n degree of all the nodes, right? I'm saying, so that we can apply the topological sort pretty easily, guys. So the n degree is going to be useful for pretty much n degree, guys, pretty much the amount of edges coming into a node, right? And the out degree is the amount of edges going out of a node. You know what I'm saying, make sure that you guys get those vocabulary down pack, right? They're very, very important, right? So the n degree, for every node, right? So for 0, it has 0 n degree because there aren't any edges coming into 0, right? And then 1, 2 has a n degree. 2 has n degree of 1, right? All right. Because there's one edge going into it, and 1 has n degree of 1 because there's one edge coming in. 3, right, has n degree of 2 because there are two edges coming into 2, right? 3, I mean, right? So I pretty much build the graph with this data that was given to me, right? You know what I'm saying? Based on this relationship that we have here, guys. So yeah, so right now we start off, right? So that's the initial graph, right? This one. And then what we do, guys, we know that we pretty much, first things first, right? We add the hue, right? So we know that the way it works right now, we build a graph, right? And then after we build a graph, we loop, so we pretty much find all the source nodes, right? All the sources, right? Pretty much nodes, I'll find all the nodes with n degree of 0, you know what I'm saying? All the nodes with n degree of 0, we add them to the queue, right? So they could be processed, the initial process, right? I'm saying, and then based on that, right, we start doing the topological sort, and then we do the breadth first search traversal of the graph, guys. Pretty simple stuff, right? So initially, there's only one node with n degree of 0, right? So we add 0 to the queue, right, for it to be processed, right? So we process 0, and then we process 0, and then we add it to the output result, right? That's, you know what I'm saying? That's what's going to hold the output result. So after we're done processing 0, right? So we take 0 out, right? I'm saying node, so say node 0, right? So process 0, we take 0 out the queue, right? And then we put 0 to the output, right? And then after we do that, right, we decrement the n degree of all of our what's it called, of our child nodes, right? So 0 has 2 child, right? It has 2, and he has 1 as a child, right? So as a result, guys, it's gonna, we decrement the n degree of both 2 and 1, right? So 1 minus 1 is 0, right? That's why I have 0 there. So 2 had an n degree of 1, so we subtract 1, so we're left with 0. And then 1 had an n degree of 0, 1, right? 1, right? And then we have an n degree of 0 now, right? So we add 1 and 2 to the queue, right? So that it could be processed next, right? I'm saying. So we add them to the queue, and then we process the node one at a time, right? And so we're right here now, right? We're on this graph, right? That's how the graph looks like now, right? And then we process. So we take one thing out of the queue. So we take one out of the queue, right? And then we process one, and then we decrement the. So now we process one, right? We decrement the make sure it's clear for you guys, right? We decrement, right? So now we just processed we processed one, right? I'm saying, so now we go to every child of 1, right? And we decrement the n degree of that node, right? So 3 had an n degree of 2, right? Now it gets decremented to 1, right? And yeah, we get the 1, and then we're good. And yeah, and then we keep doing the same thing. We take 2 out of the queue, right? So now notice 2, and then we process 2, right? And then now the n degree of 3 now, I told you guys, for every node we subtract the n degree of all the child nodes, right? You know what I'm saying? So we do that, and now we're left with 3, and 3 is good, and we add 3 to the queue, and then now we process it next one, right? 3, and then we add 3 to the thing, right? And just like that, guys, we're done, and we're able to find, right? We were successfully able to find the topological ordering of the elements, right? So because we needed to take 4 courses, and did the ordering included 4 courses, right? So we can successfully say that went perfectly fine, guys. So it's that straightforward as that, guys. So let's quickly go ahead and code that up, guys, right? So pretty much, guys, what we're gonna do, we're gonna pretty much represent the graph agency list, right? I have a video on that already, so if you guys haven't seen that, highly suggest you guys go see it. So pretty much we have get the graph, right? So now we need to keep track of the n degree of all the nodes, right? Which is very, very important. So we call it n degree. And spell today, guys. Sorry about that. Hash map. So after we do that, guys, we're gonna pretty much initialize the graph, right? Make sure that we are in good shape. That's what I'm saying. So num courses, I++. So we initialize the graph where we put for every one of them, right? For every course, we put allocate memory for the list, right? And then yeah, and then we do n degree that put I, the n degree that get or default for that I or 0, I'm saying, and we do +1. Right, so we take care of that, guys. We're good so far. So now what's next, right? We initialize the graph, right? We initialize it, right? Initialize, right? And then now we're gonna build the graph, right? I'm saying, so based on the stuff that they give us, the prerequisite thing that they just give us up there, right? So prereq, I'm saying, just copy that word, the word. So pretty much after we got an u, right? It's gonna be here. So so we said that on the first we got 2, right? So the u would be 1, right? And then we go from u to v. I'm saying doesn't matter. Just make sure they keep it consistent, right? I just wanted to keep it consistent with what I have, right? So saying that we can go from U, we can go to V, right? So that's the data that I'm catching right there, right? Because they come in a pair, right? Make sure that I have it's an array, right? And then after we do that, guys, what's next, right? We do G, right? So we build the graph. G, then I get, right? Get that the list, right, of U, so I can add V to it, right? And then I'm gonna increment the n degree that put with V. So now we're gonna increment the n degree of V, right? Because we just uh added an edge to it, right? So we need to keep track of that, right? That's very, very important for us to do, guys, right? So we U points to V now, and then we increment the n degree of V. All right, so we build a graph. So we've got a nice looking graph so far, right? So now we're gonna loop through, guys. So I'm saying of all the nodes in the n degree set, right? That key set. So if, guys, if the n degree, right, of that node, right, equals to 0, then we gonna need a queue, right? A queue. So we start doing the queue of what? Of integers, right? So what we have is the type new length lists, right? Implementation of a queue. All right, cool. So we got that, and then we add that node to all the queue, right? All the source nodes, right? So, and yeah, so while the queue is not empty, right? The queue is not empty, right? Are we gonna process the nodes one at a time, right? So node is gonna be queue that pull. So we take one thing out of the queue, right? So we're gonna need so a list of integers, right? To pretty much keep track of the stuff that we have, right? New array list. So we add, so we, as we visit the nodes, right, we process it, we add it to the, I'm saying we add it to the output result, and then we visit their neighbors, which is going to be the child node, right, or child nodes, right? So we do G that, so we get that by going there, G that get node, right? So we do n degree that put child that n degree that get child, and we subtract it, right? Since we're not accounting for that parent anymore, right? So after we do that, guys, we do n degree check, right? If that child n degree is equal to 0, right? Then we could add it to the queue now so that it could be processed as well, right? It's his turn now, so it's allowed to get processed, right? So we return, guys. So before we do all of that, right, we need to return an array, right? I'm saying, so yeah, interesting. So we're gonna need to allocate some memory, right? So let's do first things first, right? So if res that size, right, is not equal to the number of courses, right? Now, I've had taken all the courses. So were we successfully able to do the topological ordering, guys? If we were successfully able to do the topological ordering, right? Then we could yeah, we're good, right? And then what we're gonna do now next, guys. So if we're all right, that means if we skip this, right, we're able to get here, right? That means we're successfully able to do the topological ordering, right? So what we're gonna do here, right? We're gonna need to allocate memory for our results, right? So output, I should call this a different name, but it doesn't matter. Output, you int array, right? So the n array is going to be of size, res that size, right? Pretty much we're just converting that into so what we're going to do, guys, is going to be quite intuitive. Is less than the res that size, I plus plus. So we do res, so no, we do output of I, right, equal to res that gets I, right? And then just like that, we just return the results, output, I mean, right? So this was quite long, guys. So we have the graph, right? We initialize the graph, which makes sense, right? We build the graph, right? Get a U, get V. We U points to V, right? And then we get an integer incremented by 1. We get the Q, we check all the nodes, see if there's any degree of 0, and then we add it in there, and then we get the results thing, and we do the search reversal of the graph, right? We get a node out of the queue, add it, process it, visit our child nodes, right? Any degree child, right? Subtract it. If it's equal to 0, we add it to the thing, and we check the size of the ordering, right? Right, the ordering that we have here, right? If we're able to take all the courses, right? We're able to visit all the nodes, right? Right, take all the courses, right? And we were good. If we weren't able to, return an empty array, right? Yeah, and then we allocate memory for the output result, and then we return the output result, right? It looks pretty good to me, man. Probably missed something, but doesn't really matter. Oops, what was I thinking here? So when we initialize it, we put everything for a 0, right? I'm definitely tripping now, guys. Should work now. Yeah, it looks pretty good, like I thought. Let's press submit. Perfect, guys. We're able to pass all these test cases, guys. So if you guys, understood my thought process, if you guys, enjoyed this video, make sure to give me a like, guys. If you guys are new here, subscribe to the channel because I'll be doing a lot of other videos just like this one. So thank you guys for watching, and I'll see you guys in the next one.